Think we can solve this system? I'm pretty sure we can. What I'm going to do is I'm going to start out by naming each one of these equations. I'll name the top one equation 1, the middle one equation 2, and the bottom one equation 3. Before we jump into the solution here, let me give you a bigger picture of what it is that we're doing. You know, back in the beginning algebra course, you learned how to solve things like this. Maybe, like what if you had 2x equals 4, right? You have one equation and one variable. Then in the last section, we built it up a little bit more. What if you had an equation that looked like this then? 2x, let's put another variable on, 3y equals 4. But then we have two variables, so we need two equations. So maybe you have another equation. All right, so we have a method for solving this one back in beginning algebra, and then maybe an intermediate algebra, or here, in the last section, we saw how to solve these. Now we're just going to build it up one more. It's what we do in mathematics. We start at a lower level, crank it up a little bit, make it more sophisticated, and crank it up even a little bit more. So now if we wanted a third equation, we would have another variable. Say we had 2x plus 3y. Now add in a z. But now I've got three variables, so I need three equations. So maybe I have 3x, then I have a 3y and a minus 3z is 4, and then I have a 3x minus 6y and a plus z equals negative 3. Now the general idea is to take this one, convert it back to this one, and then take this one and convert it back to this one. All right, so that's a big picture of what it is we're going to do, so let's actually start doing it. Well, let's get rid of all this. All right, so what I'm going to do here is I'm going to eliminate z by kind of pivoting on row 1 and 2, and then row 1 and 3. So my plan is to eliminate the variable z using, first of all, 1 and 2, then 1 and 3. So I'm going to use equation 1 and 2, eliminate z, and then I'll use 1 and 3 and eliminate z. And that'll take me down to just a 2 by 2. Let's see how it works. So let's do this. Let's use equation 1 and 2 to eliminate z and get x and y. So I'm going to use equation 1 and 2. All right, here's 1 and 2, and I'm going to eliminate z. So I focus in on those coefficients. I want them to be opposites. The smallest number they both divide into is 6. So I'm going to make them 6s. So I'm going to multiply this equation 1 by 3, the second one by 2. But I need a negative multiplier, right? Because they're both the same sign, so I need opposite signs. So I'll multiply this by a negative. So here's the plan. Negative 3 times equation 1 plus 2 times equation 2. Right, that should do it, right? If I multiply this by negative 3, I'll get positive 6. Multiply this by 2, I'll get negative 6. All right, so let's do this. Multiply everything in that top equation by negative 3. So let's run through it. Multiply everything by negative 3. We'll get negative 6x minus 9y plus 6z equals negative 12. Let's just check that multiplication. I don't want to make a mistake early in the game here. So multiply everything by negative 3. We'll get negative 6, yes. Negative 9, yes. Positive 6, yes. Negative 12, we're good. Now, multiply everything in the second equation by this 2. So I'm going to multiply through here by 2, getting 2x plus 6y minus 6z equals 8. Now let's add these two together, and we will get negative 4x minus 3y. The z's are gone, right? 6z minus 6z is 0, equals negative 4. All right, so here's a new equation. Let me circle it so I can find it later. And I'm going to name that equation number 4. So what we just did is we used equation 1 and 2, and we eliminated the z, getting this equation with just x and y. Now what I'm going to do is I'm going to use equation 1 and 3. So it's like I'm pivoting here, right? I'm going to do this. 1 and 2, and then 1 and 3. So what I'm going to do is I'm going to use 1 and 3, right? Use 1 and 3 to eliminate z and get x and y. So focus in on those coefficients on 1 and 3. All right, they're pretty close already. They're opposite signs, first of all. Smallest number they divide into, 2 and 1, is 2. So I really don't have to do anything to the top equation, but I am going to have to multiply the bottom equation by 2. So let me write that out here. Here's my plan. It's going to be 2 times equation 3, right? 2 times equation 3 plus equation 1. Right? I don't have to do any multiplication to equation 1 because we already have that 2. So I'm going to double this one, add it to this one, and the z's will be gone. Now I'm going to circle that so I can find it again. And I'm going to name that one equation 5. Here's where we started. We started with 3 equations and 3 variables. We did a lot of work, and we reduced it down to 2 equations and 2 variables, which we know how to solve. So let's use our standard method. What I'm going to do here is I'm going to eliminate y and get x. All right, so let's try that. I'm going to eliminate y, get x, and then we'll eliminate x and get y. All right, so let's eliminate y and get x. So focus in on those y's. Smallest number they divide into is 9. That's nice. That's already a 9. But they have the same sign, so I need a negative multiplier. So I'm going to multiply this by 3, but how about if we try negative 3? That'll make it positive. So here's the plan. Negative 3 times equation 4 plus, no change on equation 5. So take that negative 3, multiply it through every term in equation 4, and we will get what? Negative is positive 12x, positive 9y equals positive 12. And equation 5 stays the same. We'll get 8x minus 9y equals negative 2. Add these together. We'll get 20x equals 10. Oh, nice. Divide, we'll get what? 10 over 20. So x is a half. All right, I got a half for x. And now the plan is to eliminate x, and that'll get us y. So focus in on these coefficients of x. Smallest number they divide into is 8. Already have an 8 here. So we just have to multiply that top number by 2, right? They're already opposite signs. So let's write it out. Here's our strategy then. It's going to be 2 times equation 4 plus equation 5. And here's what it looks like. Multiply that equation 4. Everything gets multiplied here by 2. So we're going to get what? Negative 8x minus 6y equals negative 8. Equation 5 stays the same, right? 8x minus 9y equals negative 2. Add these together. The x's go out. We get negative 15y equals negative 10. Y is equal to negative 10 divided by negative 15. Y is 2/3. Now we've got x, we've got y, right? We have x, we have y. We just now need to get z. So I know what x is, I know what y is. I can take these values and put them into any of these equations. I can put x here, here, or here. Y here, here, or here. All right, why don't we just put them in the first equation? All right, so what I'm going to do is this. I'm going to substitute 1/2 for x and 2/3 for y in equation 1. Here's what it looks like. 2 times x, but x is a half, plus 3 times y. Y is 2/3, minus 2z, this is all equal to 4. Well, nice, the fractions are going to go, right? Those cancel. Oh, and I get what? I get a 1. Plus the 3's cancel, I get a 2. and minus 2z is equal to 4. So we get 3 minus 2z is equal to 4. I'll bring it up here. So I'm going to, subtract 3? So subtract that 3 from both sides, and we will get negative 2z is equal to 1, and divide, we'll get z equals negative 1/2. All right, so let's summarize then. We have x equals 1/2, y equals 2/3, z equals negative 1/2.